AP Stats. So we are looking now in this video, starting to look at Chapter 2, 2.1, where we're looking at locations in a distribution. So this video is going to focus primarily on reviewing the concept of the percentile and now looking at a new type of graph that measures in percentiles known as a cumulative frequency graph. So let's go ahead and look at or review first what does it mean when we talk about percentiles. So when we hear the word percentile, remember that a percentile is, so if we say we're in the, let's say 8th percentile, we're saying that a percent of the population, or in this case, we're going to be looking at a particular distribution, is less than our value, wherever we're at. So if let's say for example, I took my SATs and I got a score of 1200. So I look at my score report and they tell me, well, you scored in the 87th percentile. So what does that mean? 87, keep doing that incorrectly. 87% of those that took the test that tested scored less than 1200. That's what that percentile means. Now, when we graph, a graph that kind of helps us to look at percentiles in a distribution is what we call a cumulative frequency graph. So off to the left here, I have an example of a cumulative frequency graph. So this graph is measuring scouts' heights. So we have like a bunch of Boy Scouts, and we went ahead and we measured the heights of these Boy Scouts. So in a cumulative frequency graph, so you'll notice here, it says number of scouts. So we have cumulative frequency. So we see here, this is measuring how many scouts we have. So when I read this, let's say first dot right here, at 130, so height is along the x-axis and number of scouts over here on the right. So when I read this dot here at 130, it looks to be like around, let me erase that so you can get a clearer dot here. So this is, the tick marks here are going by twos. So 2, 4, looks like about 5 because it's in the middle there. So this is at 130, I'm going to put the coordinate, it's 5. So that means that for a height of 130, 5 scouts, so I'd read this as 5 scouts have a height of 130 or less. Okay, because, and this is where the name this is where the part of that name comes from, we are accumulating the frequency. So as we go, let's say to the next point here, so at 140, it is at a value of 10, 12, 13. So I would interpret that as there are 13 scouts that have a height of 140 or less. So this 13 is including those 5 that we already counted earlier. So this is accumulating. So this is a feature of cumulative frequency graphs, is that the graph will always continue to get larger and larger. So let me write over here. Characteristics of our cumulative frequency graph, it is always increasing. Okay, because as we go from left to right, we're going to keep adding more people in that meet that particular height or less. So again, another example, if let's say I get to this point right here at 170, I'll put the coordinate up here this time. So at 170, we have a height of, this is at 50, 52, 54, 55. So again, at that coordinate, I would say, and we had was at 55. So I would have said 55 scouts have a height of, and it was 170. So have a height of 170 or less. So what that means is by the time we get to the very end here, this is the last point on the graph, this means we've measured everybody. So in total, how many scouts were part of this measurement? So I look here and it looks like 58 scouts total were part of the measurement. So by the time we get to the end, we've accumulated 100% of the population. Now, sometimes this here on the side is not going to be measuring as a frequency, but it will be measuring it as a relative frequency, meaning we would see percentages along the y-axis. So how does this connect with percentiles? Well, you see kind of like the verbiage when we measure these points kind of goes in line with measuring a percentile. So the use of a cumulative frequency graph is that it allows us to look at a distribution and be able to pick out percentiles. So for example, again, we're going to still keep using this graph here. If I said, where is the first quartile? Like what height would you have to be at to be in the first quartile? So remember, first quartile is 25%, 25th percentile. So let's go ahead. I'm going to put this in blue. So I'm going to ask, what height is the 25th percentile? Okay, so I said earlier, because I looked all the way here at the end, that we had 58 scouts total. So 25% of that 58, we can figure that out. So 58 times 0.25, and I'm going to use my calculator here to quickly figure that out. 58 times 0.25. So that's 14.5. Okay. So what I'm going to do is I go to my graph, and obviously I can't have half of a person. So I'm going is to round down. So at 14, so 10, 12, 14. So that's this part right here. So I see that that corresponds with a value around 142 centimeters. So this would be at 25%. So a height of about 142 centimeters would represent that 25th percentile. Let's say I wanted to get the third quartile. So that would be what? 75% of the data. So what would be Q3 in this particular graph? So I would go, okay, well, again, I had 58 total. So I would do my calculation. Whoops. I do my calculation again of 58, but this time it's times 0.75. So that corresponds with a 43.5. So again, I'm going to round down. So that's about 43. So 42, 43. And I'm going to go across until I hit the graph. So right there. Boom. And then I come down like so. So it's like around 156 centimeters would be considered that 75th percentile. So this is Q3, and then here, this would have been Q1. So from this graph, I can start to, and I could do the same thing like, well, where's the median? So the median would be 50% of the data. So that would be 25, 29, right? Let's double check. Yeah, 29. So if I go to 29, I can draw or know where the median is. So this would be Q2, or the median for the data. So I can see by getting these numbers, you can even start to convert this cumulative frequency graph into a box plot. So that way you can describe what is happening with the distribution. So that's one of the uses for our cumulative frequency graph. Another way we can look at the graph is to see, well, where do I see a lot of growth happening? So the more the graph starts to have the steeper the incline is on the graph, that means the more growth is happening in the graph. So if you look here from the Q1 to Q2, I have a very steep graph. So there's a lot of growth here because we went from having, what was it, about 14 scouts to then going up and having 29 scouts. So a bigger growth here than over here. This starts to become less steep and we don't get as much growth there. Then over here, this represents 25% of the data, but if you measured, oops, let me go back and erase this. If you measured the height, then again, the growth here wasn't as much as maybe the growth you had experienced here. So the steeper the incline on a cumulative frequency graph, the more growth happened in that part. Now again, a cumulative frequency graph is always increasing. We're never going to see something like this ever happen in a cumulative frequency graph. Because if this were to happen, this downward turn means all of a sudden you were measuring people and then people started disappearing. That can't happen. At best, the graph would just kind of level out. Meaning, from here to here, I didn't really pick up anybody else. Which in that case, the graph would have just then stopped here. I wouldn't keep going. But that's what a leveling off would mean is, okay, nobody else was added in there to continue the graph. So like, could I keep extending my x-axis further and further past the 180? Sure. But what would the graph look like? Well, if I don't measure anybody else, then it just kind of stays flat because I don't have anybody else to count. So that's some of the uses for a cumulative frequency graph. So you will be asked, like we've been already asked before, to sometimes describe the distribution. And you might be provided with something like this, a cumulative frequency graph. And through this example, you can see I can extract that 5-point summary if I needed it from this graph to then maybe turn it into a box plot, which might be easier for me to describe the distribution. So again, if you found this video helpful, please make sure to hit a like on the video, and I will see you guys on our next video.